Relative cumulative frequency is another way to display data, and this one's going to be a bit weird to grasp. It's not as important as some of the others, but if you have questions, I still encourage you to ask. Still try and make sense of it, because you'll see why it's useful in a bit here. So, relative cumulative frequency. This is also called an ogive. So if you see this word, you know it's the same thing. These are the same. And an example of what that might look like is something like this. I believe in the textbook they've got age, and the vertical column will always be percentage. The horizontal column will always be some other variable. And this was like age of president at inauguration, which, if you're not familiar with kind of American political terms, inauguration is when they're brought in. I believe that's actually going to be a general term. And this, in the book, it's because it's an American-based textbook, it's about American presidents. So if we're way down here at 0 years old, none of the presidents were inaugurated at that age. So we're going to have a lot that is 0. And then eventually, this should be not a number, it should be percent. And then at some point, it increases, and then it levels out. Because at some point, we get to an age that covers all of the presidents. And that's what this is. It's a relative cumulative frequency. So what we're saying is, at this point, how much have we kind of accumulated of the percentage of people that have been inaugurated at this age or lower. So how do we calculate it? First, create a set of classes just like a histogram. So in that example, we maybe divide it into every 5 years. So from 35 to 40, 35 to 40, 40 to 45, 45 to 50, etc. Then you're going to find the you're going to sort everything into those. So you're going to get all your counts. So how many people were inaugurated between 35 and 40? How many between 40 and 45? And then from this, you can find the relative frequency of a given category by dividing the number divided by the total. So if 5 people were inaugurated between the ages of 50 and 55, out of a total, just for rounding here, we say of 40 presidents, then the relative frequency would be 5 out of 40, converted to a percentage, so that's going to be 1/8, which is, what, like 15, 20, having a little hard time with my math. It's maybe in like the 11-12% range. So 11 or 12% would be the relative frequency. Once we've got all the relative frequencies, we will then find the cumulative frequencies. And this is by adding this for equal or lower. So you're basically saying how many people were in this category or below this category. So we can just add those up. Technically, if you want to be a little bit better, you should add up all the people in that category or lower and then divide by the percentage. Divide by the total and get a percentage. So it's going to include everyone that's in the lesser categories and the category you're in. And then finally, find the relative cumulative frequency by dividing the cumulative frequency by the total number of observations. And this isn't super important. Sorry, I messed that up. I'm just realizing now. Cumulative frequency is just add the categories. Relative cumulative frequency is divide the previous. So when you see relative, you're going to divide by the total number. So relative frequency is just that category divided by total number. Relative cumulative frequency is the cumulative frequency divided by the total number. Cumulative frequency is everything up to that point. It's how much has accumulated. This is one that, again, you won't need to actually create this by hand, but you should kind of be aware of how it was created so you know what it means. So let's look at how you then take that and create it into a chart. So you did all these calculations, you found all these numbers. Again, we will have computers do it for us in this class, but I want you to know the idea. You're going to label the horizontal axis with the data values and the vertical axis with percentages. Then you just plot the data using the lower bound and relative cumulative frequency. So if at 40 you had 0%, you do 40 and below, you do 40, 0. Then if there were two people between 40 and 45, whatever percentage that is, at 45 you put at the 2%. And this way your number will always go up and it will approach to 100% once you've included everyone in your data set. So it will always range from 0 to 100, unless you've got things in the very far left to start with. Then connect points, and this is useful for easily telling what percentage of data is below, above or below a given value. So we've got an example here of the average daily commute, and this isn't in percentages, it's in ratios out of 1. So just imagine multiplying all these numbers on the left by 100, and you get percentages, right? 20%, 40%, 60%, 80%, 100%. So now we can say what percent of people have a commute that is shorter than, say, 25 minutes. What I do is I'd look at the 25-minute mark right here. And I know this yellow is going to be really hard to see on the white, but I'd come up, drag across, and I can eyeball it. We can do this more precisely if we got out a ruler, but about 70% have a commute that's 25 minutes or less. You know, down here, like 5% have a commute that is 18 minutes or less. 20% have it at 20 minutes or less, and you can kind of keep going up. And then at a certain point, 31% or 100% of people have or whatever they're measuring, this wouldn't be people because it's average daily commute. I guess it could be. In this data set, 100% of the people had an average commute of 31.9 minutes or less. So that's why this is useful. We can also see what percentage have something more by doing the opposite. So if 70% of the people have an average daily commute of 25 minutes or less, 30% have an average daily commute of more than 25 minutes. So that's an example of an ogive, or in other words, a relative cumulative frequency.